Okay, good morning, everyone. Yesterday, in the previous class, we discussed about Bayes theorem and how Bayes theorem. Today, we shall see how we can make use of Bayes theorem in Bayesian learning, that to solve our classification problems. Okay. In machine learning, how Bayes theorem can be implemented, which is nothing but Bayesian learning. Okay, here, take one example. Grasshopper and katydids, two types of uh, insects are there. We got the task to classify these two things based on their antenna length. Okay, both have got antennas. Based on the antenna length, let's see whether we can classify these two as whether it's a grasshopper or katydids, just based on the antenna length. Okay, here in the left side, you can see various categories of grasshoppers and their antenna length. If you have got the length 6, 5, 4 of various lengths, okay, antenna of various lengths. Here also, its antenna is of various length. Okay, just based on antenna length, is it possible to classify these two insects into their categories? Okay, only based on antenna length. So here, blue dot indicates the antenna length of grasshopper. Uh, Red marks indicates the antenna length of katydids. So if you plot the histogram for these two things, histogram will look like this. Okay, blue histogram is for antenna length of grasshopper, and this red one is for katydids. Histogram for their antenna lengths. Okay, each and every one has got its own length of antenna. And again, if you instead of histogram, if you apply normal distribution and plot the graph, it will be like this. Okay, this is histogram and normal distribution. It will be like this. Okay, normal distribution. Uh, See, I'm not doing any machine learning or anything to identify or classify these two things. Other than those things, if you want to do the classification, how we can proceed, other than machine learning or any learning techniques, any Bayesian application, if you want to categorize it, how we can proceed. That's what we are just trying to check. Okay, normal distribution, it will be like this. Now we want to classify an insect that we have found, and its antenna length is 3 units long. Okay, we have the data of grasshopper and katydids, that normal distribution curve you have. Now we want to classify, there is a task to classify new insect, and its antenna length is 3 units. Okay, that is our task. So simply seeing like, see, probability of Cj slash D means probability of class Cj given that we have observed the D. That is what we are trying to find out. Okay, so that is the new insect antenna length is 3, which is denoted here. If you are asked to classify it, you can see here these 3 in the katydids, it is giving us the number 2, and here it is 10. Okay, so probability of this new insect, okay, it being grasshopper. Okay, this is the new data. Probability of it being the grasshopper is equal to, okay, 10. Probability of grasshopper is 10 divided by 10 plus 2. Okay, divided by 10 plus 2. So that probability is 0.833. Probability of this new insect being katydid is equal to, its value is 2, 2 divided by 10 plus 2. So that value is 0.166. So if the antenna length is 3, probability is that that is a grasshopper because its probability is higher. Okay. Similarly, let's see if we found out one more insect of antenna length 7, to which category it belongs to. Okay. Probability of this grasshopper, which antenna length is 3, is equal to, in grasshopper, it gives the number 3. Okay. 3 divided by 3 plus 9. So it is 0.25. Probability of it being katydid, antenna which antenna length is 7. So here it cuts the curve at 9. 9 divided by 3 plus 9. So it is 0.750. Here it is saying this insect belongs to this katydid family. Okay. Similarly, one more antenna length, if you get it 5, you can see here it intersects both at the same point, 6, 6. So 6 divided by 6 plus 6, 6 divided by 6 plus 6, the probability is same. Okay, now you cannot say that exactly to which family it belongs to because probability is same. Okay, this is just the general visualization of this classification without any proper logic. So that was like simple visual classification. Okay, but now we shall see same thing how you can solve using base classifier. How does a base classifier uh, exact mathematical formulations and all if you use, how you can solve the same uh, problem. Okay, that's what. In base classifier, what happens is we'll find out the probability of the previously unseen instance belonging to each class, then simply pick the most probable class. Okay, this statement clearly defines what you are doing in base classifier. Find out the probability of the previously unseen instance. Okay, we have an unseen data and we'll try to find out probability of that unseen data belonging to each class. If there are two classes, we'll see this unseen data, what is the probability it belongs to class 1, what is the probability it belongs to class 2. Okay, and then simply pick the most probable class. If the probability of it belonging to first class is higher, we'll pick the first class. Okay, this statement clearly defines what you are going to do in base classifier. Okay, find out the probability of the previously unseen instance belonging to each class. So we are going to calculate the probability. And whatever probability is highest, that we'll pick as the respective class for the data. Okay, naive Bayes classifier, Bayes classifier, it is also called as idiot Bayes or naive Bayes, simple Bayes. Okay, so these are the few names for naive Bayes classifier. Again, yesterday also we saw this formula, Bayes theorem formula. Same thing we are going to Bayes theorem. It states that the P of Cj slash D is equal to P of, see yesterday here P of H comma H slash D, we spoke about hypothesis. Same thing, it's different in a different notations. Uh, when I say hypothesis, you'll get confused. For that reason, it is mentioned in this understandable form. Okay. Here I will explain what are these each and every terms. Yesterday you saw that P of H slash D, that is hypothesis, slash D is equal to P of D slash H. Here same thing written in a different format. So what is P of C J slash D? Probability of instance D being in class Cj. Okay, you got the new data. Okay, new data. In our previous case, that new data was the antenna length. Okay, probability of this new antenna length being in class Cj. Okay, you have to calculate if there are four classes, you have to calculate this for all four classes. You have to calculate the probability of this data belonging to class 1, class 2, class 3. Cj means it can be C1, C2, C3. There may be 4 or 5 class classifications, 2 class classifications. Okay, probability of this data belonging to this class. That is what we are trying to find out here using Bayes theorem. Okay, probability of instance D being in class Cj. Okay, this instance being in this class. Okay, it may be class 1, class 2. That is what we are trying to find out here, which is equal to probability of D slash Cj. That means probability of generating instance D given Cj. That is, we can if you are in this class, what is the probability you'll get this feature? Okay, that probability here. P of Cj means probability occurrence of that class. Uh, in the entire set of example, what is the probability of that particular class? Okay, P of Cj means in that particular class, what is the probability of that particular class? Okay, P of D is nothing but probability of instance D occurring. Okay, uh, again, uh, probability of usually P of D will just ignore, okay, because it will be same for all the classes. Because that instance will occur in every class. For that reason, probability of instance D occurring. I will just show you, okay, probability of D, what it will be. Okay, so this is Bayes theorem. Now, just assume to one example, okay. You will better understand that formula here. Assume that we have two classes, C1 male, C2 female. Okay, if I get one name, I should be able to classify that name as either male or female. That is our task. Okay, we have two classes. C1 is equal to male, C2 is equal to female. If I get one name, I should be able to classify that name as either male or female just by seeing the name. Okay, we don't know who that person is. Just by seeing the name, we should be able to classify that person as male or female. Okay, so here we have taken one example, Drew. Okay, Drew can be Drew Barrymore or Drew Carey. Okay, it can be any of these two names, but I got the name as Drew. What is the probability of being Drew is a male or is a female? If that is the task, if you are asked to apply the Bayes theorem, it will look like this. Okay, probability of Drew being in male class is equal to probability of Drew, okay, slash male. How many persons are there by the name Drew? Males. Okay, that is the probability. Is it clear? This is our new data for which we are trying to calculate the probability of this being the male. Okay, for that we need this previous data where, okay, probability of Drews being male. How many Drews are there as male? Okay, that probability we need. And probability of male population in the entire population, what is, how many male population are there? Okay, and this is probability of Drew. In the entire population, how many Drews are there? Okay, probability of Drew. Is it clear? I hope you can relate that example to this formula. Okay, this is new unseen data. I want to find out that is Drew. I want to classify it, calculate the probability of this being male and then female. Okay, CJ, C1, C2 is male and female. This is the new Drew data. I want to classify it. For that, you need to know how many Drew probability of Drew males are there, Drew females are there, and probability of male and probability of female. Okay, these things we need. So let's do with an example. Okay, there is an officer, okay, whose name starts with Drew. Now our task is to find out whether that officer is male or female. Okay, this is the officer. Oh, okay. We need to find out whether this officer is male or female using Bayes theorem. And we have this data. You can see here we have the data, and in data we have names and sex. They're related. So Drew appears 1, 2, 3, 3 times. Uh, Data of the officers and Drew appear 3 times. And this is the sex, male, male, female. This list is there. So using this given data, we have to apply this formula and find out the probability of Drew being the male or female. Okay, using this data. Let's apply this thing. Okay. First thing is probability of Drew being male. That I need to find out. Okay, probability of Drew being male, which is equal to, this is nothing but probability of Drew male. Okay, this first probability of Drew male. So Drew name is here. It is male 1 time. Okay, only 1 time. So three male cops are there. Among them, Drew is present only 1 time. So it is 1/3. Is it clear? This part. Probability of Drew being male. Three male cops are there. Among them, only once Drew is male. So 1/3. Star. Probability of cops being male. 8 examples are there. Among them, 3 times cops are male. Okay, P of Cj. 8 cops are there. Among them, only three are male cops. So that is 3/8. And probability of Drew. Okay, 8 names are there. Among them, Drew name is only 3 times. So that is 3 by 8. See, as I said, this last denominator is not required because here also it will be 3 by 8, here also it will be 3 by 8. So we can just ignore that. That's not needed. Value will be finally same itself. If you divide both the numbers by 3 by 8, it doesn't matter for our probability. So P of D is always same. We can just ignore it. Is it clear? This factor we can ignore. Among 8 names, Drew appear 3 times. So 3 by 8, 3 by 8. If you compute it, you'll get 0.125. For male, probability of Drew being male is this much. Okay, now let's see probability of Drew being female. Okay, probability of Drew being female. Here, 5 times female names are there. Okay, among those 5 times, 2 times Drew is present. So that is 2 by 5. Is it clear? Probability of Drew being female. So 5 times female, among the cops, 5 female cops are there. Among them, Drew is 2 times. So 2 by 5. Star. Okay, among 8 cops, 5 are females. Probability of cops being female. Okay, 5 by 8. P of CJ. Female cops. So probability is 5 by 8. So if you compute it, you'll get 0.250. So probability of Drew being male is 0.125. Probability of Drew being female is 0.250. So what does that mean? It clearly indicates that this cop is female. Okay, this probability is high. So this cop is female. Is it clear? Have you understood? Okay, since the probability of based on the probability Bayes theorem, we have found out probability of Drew being female is 0.250, which is greater than male probability. So we can say that this officer is female. See, definitely you will get 2 problems on Bayes theorem. One, to apply the Bayes theorem directly. Okay, that is to apply this formula and solve it. One more is naive Bayes classifier. They may ask you to apply naive Bayes classifier and classify the one particular example. And it is pure probability problem. Okay. Only thing is you need some common sense. You need some table. By looking at the table itself, easily you can mark these things. And one more thing is this Bayes theorem. While solving analytical reasoning or aptitude questions, you might have noticed a lot of probability questions will be there. Okay, for you, particularly for students, probability is very important. Okay, Bayes theorem, you'll see a Bayes theorem everywhere in mathematical applications. Okay, this is very important. Only thing is you need to understand this thing. If you just by heart, you'll not understand this one. Okay. Just see this example. This is a very good example. By just seeing this example, this table and this formula, easily you can relate the data and the terms. Is it clear? Okay, so this is a very simple example. Okay, we are trying to classify one name into male or female class. Okay, based on this data. Total 8 names are there. Among those 8 names, we are just trying to find out how many times Drew name is being female. Okay, that is what we are doing here. A simple data which we have applied and we try to calculate the probability of this thing. Okay, very simple problem, very simple task. If you understand this, you can further problems will get complicated. You'll get the idea then how to solve these problems. Is it clear? A very simple thing, very simple Bayes application. So this is naive Bayes classifier. Okay, in real, yeah, I will say first I will explain naive Bayes classifier application itself. Then we shall again come back to the algorithm. Okay, there is no algorithm, just a modification for Bayes theorem, and you'll get the naive Bayes classifier. Okay, simple modification to the Bayes theorem, and we'll arrive at naive Bayes classifier. We shall come to this later. First, let's see why we need naive Bayes classifier. Okay, Bayes theorem. This is Bayes theorem, proper Bayes theorem. This example, which we have applied. Let's go to the situation where we need this naive Bayes classifier. Okay, in the previous class, two cases, we just classified the example based on antenna length, that is whether it is a grasshopper or katydids based on the antenna length, or we classified one person based on the name. Only two values based on the one value. Okay, either antenna length or name. Based on that simple value, we classified the person or the insect. Okay, if you have more features, what you'll do? Okay, if the same task, if the data is like this, see in the previous case, table was simple, just name and sex that was present. But if the table is like this, okay, I need to identify the cock, whether it's male or female, based on the name, not just name. We have other features like his height, eye color, and hair length. Okay. Previously, it was just name. Now we have other features. These three additional features are there. Okay. Name along with these features included. We have to consider all these things to classify that person as male or female, pop as male or female. So now the task got complicated. Okay, because we have to consider all these factors while doing the classification. So in this case, how we are going to do? So that is where we will modify that Bayes theorem a little bit, and we'll derive the naive Bayes classifier. Okay, so we'll proceed like this. Okay, you can see here P of D slash Cj. This is what is present in the formula. Okay, here it was previously it was only one value, that is name, which belongs to this class. Now we have so many features. So P of D1 slash Cj multiply P1 D2 slash Cj. So if there are 4 or 5 attributes, we'll multiply the probability of that attribute belonging to that class. Okay, if this is one attribute, second attribute, third attribute, we are going to multiply that entire set of attributes. That is the product of the attributes. Here you can see here, okay, P of D slash H, which is nothing but product of P of AT, product of A1, A2, A3, that is the attribute, set of attributes. That is what we'll do in the naive Bayes classifier. Okay, probability of Cj generating the observed value for feature 1, then for feature 2. All the products we'll take. Okay, coming back to our example. Okay, probability of this officer being in this class is nothing but probability of that officer is over 170 centimeter. If yes, okay, probability of that officer eye color is blue, okay, and belonging to that class. Probability of that officer, uh, one more hair length being short, okay, belonging to that class. That probability table you have to write down. So which will be like this. So whenever you see an uh, example table, what you need to do is you have to draw the table like this. Okay, that lengthy table you have to simplify and you have to write it like this: male, female, over 170 centimeter. Male, what is the probability? 0.15. Over 190 centimeter. It is, if it is yes, what is the probability? If it is no, what is the probability? In female also, if it is yes, what is the probability? If it is no, what is the probability? Okay, long hair, male and female. Yes, no, yes, no. So you have to write down the probability of all these classes. Okay, you have to make the table like this. Okay, See, that was two class classification. Okay, male and female classification. If it is three class classification, that is, I want to classify these animals, cat, dog, and pig, based on its mass, color, height, and all. So what you have to do, again, you have to draw the table like this. Cat, if the mass is 10 kg, yes, what is the probability? Cat, if the mass is less than 10 kg, what is the probability? Dog, if the mass is 10 kg, greater than 10 kg, what is the probability? If it is less than, what is the probability? See, for each and everything, you need to find out the probability based on that table. Okay, color also. Probabilities you have to write down. Here, probabilities. And then we'll apply the formula and we'll do the multiplication. Okay, over 6 foot, over 200. Similarly, whatever data is given, first thing is you need to write down the probability tables for them. Okay, probability tables you have to write down and then go on applying the formula and find out which probability is highest to which class that given new data belongs to. Okay, so this is the example. You have seen this data again and again. Now what we shall do is play tennis will apply naive Bayes classifier. So whenever a new data is given, okay, we shall try to find out play tennis is yes or no. For that, you have to draw the small probability table for outlook, for temperature, for humidity, for wind. Okay. For these things, you have to draw the probability table. When outlook is sunny, overcast, rain, what is the probability? Latency is yes. What is the probability? Latency is no. For temperature, cool, mild, hot, what is the probability? Yes or no. Humidity also you have to find out. Wind also you have to draw the table. See, you can do without tables also, but if you draw the table, it will be very easy to solve these problems. Definitely, you will get one problem on this in the exam. That is the best way. You draw the tables and then it will be very easy to solve them. Okay. So this example we shall take up in the next class. I will draw the tables and I will show you how you can make it very simple and solve these things very easily. Is it clear? Okay. Thank you.